In this example, we want to solve, using Cramer's rule, the system consisting of the following equations. X plus 2y plus 3z is equal 4, 4x plus 3y plus 2z is equal 1, and negative x minus 2y minus 3z is equal 2. We'll start with computing the main determinant of the system. That determinant is form of the coefficients of x, y, and z. Coefficients of x are 1, 4, and negative 1. Coefficients of 2, which form second column, are 2, 3, and negative 2. And coefficients of z are in the third column, and they are 3, 2, and negative 3. We use the first row to expand this determinant. So the first entry in the first row is 1. We multiply it by the determinant obtained by crossing out the first row and the first column. Then we'll subtract the product of the second term in the first row by the corresponding 2 by 2 determinant, which is obtained by crossing out the first row and the second column. The numbers are 4 and 2 in the first row and negative 1, negative 3 in the second row. And then we'll add the product of the last term in the first row, which is 3, and multiply by corresponding 2 by 2 determinant obtained by removing the first row and the third column. The numbers are 4, 3 and negative 1, negative 2. Now we'll compute the value of each determinant and compute the value of that determinant d. So the first determinant is negative 9 plus 4. Then we'll have minus 2 times the second determinant is negative 12 plus 2. And the third determinant multiplied by 3 is negative 8 plus 3. When we compute the value of that expression, we obtain 0. So the main determinant is 0, and according to the theorem, the system has either no solution or infinitely many solutions. Everything depends on whether dx, dy, and dz are all 0, then we'll have infinitely many solutions, or if one of the dx, dy, dz is non-zero, then we have no solutions. So we need to compute the value of those determinants. Let's start with dx. This is the determinant that is obtained from the main determinant by replacing column of x coefficients by the column of the numbers on the right hand side of the equation. So the numbers are 4, 1, and 2. The column 2 and 3 remain unchanged. And again, we'll use the first row to compute that determinant. So it's 4 times determinant with numbers 3, 2 in the first row and negative 2, negative 3 in the second row, minus the second number in the first row times corresponding determinant. So that's going to be 1, 2, 2, and negative 3. And then we'll have plus 3 times determinant consisting of numbers 1, 3 in the first row and 2 and negative 2 in the second row. Computing those values, we'll get 4. The first determinant is negative 9 plus 4. Then we'll have minus 2 times negative 3 minus 4. And then we'll have plus 3, and the last determinant is negative 2, negative 6. And when we compute this value, we'll have negative 30. So since dx is non-zero and d is 0, we can say that this system has no solution.